So, lesson 4.6 for 9:30. We are at the very end of what we can do with exponents. Yesterday, you guys talked about how, doing all of those properties that we learned at the beginning of the unit with fractional exponents, and it all worked exactly the same. All the properties were the same. You just used fractions instead of whole numbers. But maybe as that came up, you're kind of wondering, what the heck does a fractional exponent mean? So that's what this lesson is all about. So this kind of takes it one step farther of, yes, you can do all these properties with exponent, as fractional exponents, but what does it mean to have a fractional exponent? So that's what we're going to talk about. So a fractional exponent actually relates to a radical or a root. So, this is kind of a new concept and one that not a lot of people really understand or have seen before, so it's kind of new. So we're just going to start off with the basics. So when we have a fractional exponent, that fractional exponent would look something like this, right? So if I have b to the 1/2 power, say, I will tell you that something to the 1/2 power is the same thing as saying the square root of b. Now, when we think about what a square root means, right, we kind of know what a square root is. We've done that before. So a square root really means, in your head, you're kind of thinking what one number times itself 2 times equals b, right? That's the idea of what a square root is, right? Now, b is just a placeholder. So, for example, if I said that I had 25 to the 1/2 power, that really means, what is the square root of 25? What one number times itself 2 times equals 25? Well, what number times itself 2 times does equal 25? What one number times itself 2 times equals 25? The answer is 5, right? So 25 to the 1/2 power is 5. I'm wondering, 1/2 meaning what's the one number times itself 2 times? That's how I get this square root, right? So that's maybe one that we could understand, but we don't have to have just a half as our fraction. So I could have, say, b to the 1/3 power. So what that would mean is this is the third root of b. Now, many people haven't really seen a third root before. So it's very similar, right? But instead of what number times itself 2 times equals b, when I have a third root, that means what one number times itself 3 times equals b. So a third root means what number times itself 3 times. So a square root, square is the other way of saying like an exponent of 2, right? So this invisible, we don't write the 2 for square root. It's kind of like one of those invisible numbers that we don't always have to write. And so that if it's just a plain square root, it's the invisible 2, and that's where it's one number times itself 2 times equals b. Well, a third root is what number times itself 3 times equals b. So again, to put it with some actual numbers, for example, if I said 8 to the 1/3 power, 8 to the 1/3 power would mean the third root of 8, right? What one number times itself 3 times equals 8? What one number times itself 3 times equals 8? What number times itself 3 times equals 8? The answer is 2, right? So 8 to the 1/3 power is the same thing as the third root of 8, which is what number times itself 3 times gives me 8, and that number is 2. So hopefully you're kind of starting to see a pattern here, right? So if I had b to the 1/4 power, that would be the fourth root of b, right? Fourth root means what one number times itself 4 times equals b. So that's what that means, right? So in general here, when I have a fractional exponent, so if I have b to the 1 over n, right, whatever n might be, any number at all, that would give me the nth root of b. So in other words, we're saying that the denominator is this degree of the root, right? How many times are you having to multiply the thing by itself? So that, I just realized I didn't leave myself enough space up top here to write down what a fractional exponent means. So I'm just going to scooch it just a tiny bit. There we go. So a fractional exponent, the denominator, helps if I can spell, I apologize. Denominator is the root, no, the degree of the root. Right? So the denominator here is the degree of the root, meaning what's that number, right, in front of the root? What are you multiplying by itself? How many times, right? So if you try one more here, maybe you guys can figure this out. So if I said, what is b to the 1/8 power? That would mean it would be the 8th root of b, right? What number times itself 8 times would give me b, that number inside. So hopefully you're getting the idea of what that fractional exponent is all about. And so now let's just try practice using it, right? So just like my examples were up at the top, now we're going to say, okay, but I'm going to actually give you a number so you can understand what it means. So if I have 16 to the 1/4 power, so remember that denominator is the degree of the root. So this really means the 4th root of 16, right? So the 4th root of 16 means what number times itself 4 times? You don't have to write this, but just in case you're still kind of wrapping your brain around it. What one number times itself 4 times equals 16? Let's see. Well, it's not 4. 4 times 4, it's only times itself 2 times. I want to know what times itself 4 times. So what number times itself 4 times equals 16? That would be 2, right? So this equals 2. Now, if you're wondering how to use your calculator to help you, once you get to this idea, so you have to write this step that says the 4th root, like no matter what, that's a required step, the 4th root of 16. But if you're having a hard time figuring it out after that, you can use your calculator. In order to type in a root that's other than a square root like this, you need to use the little button that looks like this with the X root in front of it. So I believe you have to hit the second button on your calculators, and then it's kind of in the little grayed out letters above one of the keys on the left. So you would have to type in the 4 first, so the what root, you type the 4 in first, and then you'd hit that second button and then this X root key, right? And then you'd type in the 16. So that's how you would do it on your calculator. If you really needed help. But hopefully, all of these that we're doing, in this lesson, really you should be able to figure out just knowing your perfect squares, perfect cubes, that kind of thing, without having to type it in. But that's what it is. Just be careful that you're using the X root and not the plain square root if it's a root, a different degree of a root. All right, number 2, see if you can pause your video and get it. So number 2, again, 3rd to the 1/3 power would mean that I have the 3rd root of 125. So what number times itself 3 times gives me 125? The number times itself 3 times is 5, right? 5 times 5 is 25. 25 times 5 is 125. So this is exactly the work that you would have to show. And that's it. You don't have to show anything else. If you really need to use your calculator after you write down what root it is, that's okay. But make sure you're showing that step. Okay? All right, so that was if I go from my fractional exponent to my root. What if I go the other way? So for these two, I just am giving you the root. How could you write that as a fractional exponent? So remember, if I have just a square root of 81, what I have here is, remember what invisible degree this is. This is the invisible 2, right? So that means that this would be 81 to the 1/2 power. Here on this next one, if I have the 4th root of 625, that would mean I have 625 to the 1/4 power, right? That degree of the root is the denominator. Hopefully those are pretty easy. We don't do anything else after that because, it's just practice rewriting it using the fractional exponent instead of the root, kind of going backwards of the other two. All right, so maybe by now you're feeling comfortable. This isn't so bad. But what happens if my fraction doesn't have a numerator of 1, right? So what if it's not 1/2, 1/3, 1/4, 1/8, right? What if it's something else? So for example, what if I have x to the 2/3 power? What happens then? So this will really make sure that you understand how your fraction operations with fractions, right? How I could get 2/3 using my fractions, but also your exponent properties. So if I think about this, if I have x to the 2/3 power, one option would be that this is really x to the 1/3 times 2, right? 1/3 times 2 would give me 2/3. Do we agree? Hopefully. Okay. Well, thinking about my exponent properties, when do I multiply exponents? I multiply exponents when I have a power to a power, right? So that would really mean that I have x to the 1/3 power, and then outside the parentheses to the second, right? 1/3 times 2. I multiply my exponents when I have a power to a power. All right, well, x to the 1/3 power is really the 3rd root of x, right? And then I still have that exponent of 2 outside. So it's the 3rd root of x all raised to the 2nd power. So that's how I could use that's one way to think of it. It's 1/3 times 2. Well, the other way to think of it is it could be x to the 2 times 1/3, right? I'm still multiplying my exponents, so I just have the 2 first and the 1/3 second. Okay, well, that would mean that inside my parentheses then, the first thing I would have is x squared on the inside, and then it's all raised to the 1/3 power, right? Same thing. When I have a power to a power, that's when I multiply. So this time that means that this 3rd root is really on the outside, right? So I have the 3rd root of x squared. So I could have this x squared on the inside. Now these are both the same thing. It's two different ways of rewriting the exact same thing. But if we go back and we kind of look through this, what are we noticing? Where is that denominator showing up? The denominator is still showing up as the degree of the root, right? Either way, the denominator is the degree of the root. Where is that numerator showing up? So either way, the numerator is showing up as the exponent. Whether the exponent is inside the radical or outside of the parentheses, the numerator is the exponent. So the numerator, if I have a numerator other than 1, right, the numerator is the exponent, and the denominator is the root. Is the degree of the root. So the denominator is still the same, right? Same thing, but if I have a numerator other than 1, it becomes an exponent. So now let's see how that works here with our examples. So 8 to the 4/3 power, right? So that could mean that I have 8 to the 1/3 power raised to the 4th, right? So I could put that fraction inside the parentheses, which would mean 8 to the 1/3 power is really the 3rd root of 8, still raised to the 4th, right? And keep that in red so you can kind of see how that's going. Okay, so the 3rd root of 8, well, what times itself 3 times gives me 8? That would be 2, right? So now I still have 2 to the 4th power, and 2 to the 4th power equals 2 times 2 is 4, times 2 is 8, times 2 is 16. So I can still do it, right? You just have a step after figuring out what that root is. Now, that was the first way, the way on the left. I could do the same thing, and I could say that this is 8 to the 4th inside the parentheses, and the 1/3 is outside the parentheses, right? Those were my two methods. And then if I think about that, okay, well, that means I'm going to change this 1/3 power to be my root. So I have the third root of 8 to the 4th power. Oh my goodness, hang on. 8 to the 4th power. 8 times 8 is 64 times 8. Oh my gosh, wow, yikes. I don't want to have to do that. Yikes. No way. So I'm going to pick the method where I have the fraction first, or the fractional exponent first, so I can figure out that root with a smaller number and then get my number to be even smaller and then do an exponent, right? So this is definitely the faster way, where you put that fraction inside the parentheses and then do your exponent last. All right, look over there on number 6, 25 to the 3/2 power. See if you can pause your video and do it. Let's see, so this would be 25 to the 1/2 power inside parentheses raised to the 3rd. Well, 1/2 power is really the square root, right? You can write the invisible too if you want to, but we just know that this is a square root. The square root of 25 is 5. So now I have 5 to the 3rd power. 5 to the 3rd power. 5 times 5 is 25, times 5 is 125. So my final answer here should be 125. Now again, you could go the other way, right? This could be 25 to the 3rd raised to the 1/2, which would then be the square root of 25 to the 3rd power. And again, I guess, right? But I don't know what 25 to 25 is times 25. Oh my gosh, yikes. Too big, right? So I'm going to always stick with, let's put our fractional exponent inside the parentheses. Let's get that root first, and then at the end, do the exponent. So I'm not going to show the other way anymore, but just so you know, like they're all the same, but this way is much faster and easier. All right, you got 2 more here. You could pause your videos and see if you could do them. So here I've got 1 to the 3/5 power, which would mean that I have 1 to the 1/5 raised to the 3rd. 1 to the 1/5 power is really the 5th root of 1. Oh man, you're probably like, what? The 5th root of 1? What times itself? 5 times equals 1. 1 times 1 times 1 times 1 times 1, right? The 5th root of 1 is just 1. 1 to the 3rd power, 1 times 1 times 1 is 1. That was a tricky one. But people tend to forget about the square roots or the 5th roots or the 12th roots of 1. Any, 1 times itself, however many times, is still 1. So don't freak out about that. All right, how about number 8 then? 1,000 to the 4/3 power. Well, that would be 1,000 to the 1/3 power, inside parentheses, raised to the 4th. 1,000 to the 1/3 power really means the 3rd root of 1,000. What times itself 3 times gives me 1,000? Well, that'd be 10, right? So now I have however many zeros there are, that's how many times I multiply 10 times itself, right? So now 10 to the 4th, well, that just has 4 zeros, so that would be 10,000. I didn't even need a calculator. Hopefully you didn't either. Okay, hopefully by now you're feeling comfortable, getting confident, ready to go. So the last thing that you could do with these fractional exponents, what if I'm not just doing one at a time? What if I have more than one? So if I have 64 to the 1/3 minus 16 to the 1/2. Are those like bases? No, they're not. And am I multiplying anyways or dividing? No, I'm subtracting. So these are not like bases and I'm not multiplying. So that means I can't combine these exponents at all. Not like bases and not multiplying. So I can't combine them. I can't create one base with a different fractional exponent. I don't have to worry about common denominators. I just need to do each one separately, and then when I get my answers, I'm going to subtract them. So 64 to the 1/3 power would be the third root of 64, right? 16 to the 1/2 power would be the square root of 16. Let's see, third root of 64. What times itself 3 times gives me 64? Maybe this is one you need a calculator on. But let's see. I know, let's see, 2 times 2 times 2 is 8, so it's got to be bigger than 2. 3 times 3 is 9 times 3 is 81. No, that's not going to work. Excuse me, 3 times 3 is 9 times 3 is 27. Still bigger than that. That's not going to work. Let's see, 4 times 4 is 16. 16 times 4 is 64, so this is 4. So you could still work your way through it even without a calculator, but maybe that's one that you needed. Square root of 16, hopefully you know by heart. Square root of 16 is 4. Now remember, after we get these two, I'm going to subtract them. 4 minus 4 gives me 0. So my final answer is 0. 64 to the 1/3 power minus 16 to the 1/2 is 0. All right, see if you can do number 10. Pause your video, see if you get it right. So again, different bases, not multiplying, can't combine. So I just have to do the 4th root of 81 plus, now this is a 2/3 power. So this would be, let's see, 125 to the 1/3 power in parentheses to the 2nd power outside of the parentheses. Let's see, what times itself 4 times gives me 81? 3 times 3 is 9. Times 3 is 27, times 3 is 81. So 3 is the 4th root of 81. Plus, now on this side, I have to do a little work, right? First, I have to do the 3rd root of 125 before I can do anything else. I need to write that down. Let's see. So then I have the 3rd root of 25. What times itself 3 times gives me 125. We did that up earlier, didn't we? That would be 5. 5 times 5 is 25. 25 times 5 is 125. So 5, but I'm not done. Now I need to do 5 to the 2nd power. 5 to the 2nd power is 25. So I really have 3 plus 25. So my final answer would be 28. Hopefully you got that right, getting comfortable, confident in those fractional exponents and what they actually mean. Now, you just have to be careful about what the directions say. You know, if they say use radicals to simplify or convert your fractional exponents into radicals, that's when we want to do these roots, right? Sometimes they just might say simplify using exponent properties, and that if that's the case and you have fractional exponents, then you just leave fractional exponents in your answer. But here if it says use radicals to simplify, that's when you want to actually convert them into square roots or cubed roots or 4th roots or 8th roots and get a final answer as a single number. So go ahead and practice, and hopefully you're feeling good about exponents.